Hello everyone, this is going to be the first of several short videos that I will make into a longer video on basically the second half of eukaryotes. We're talking algae and the like. Keep in mind this is two different things here. We are not just talking about algae. There is a distinct difference between cyanobacteria, which is kingdom bacteria, and the other chlorophytes that we're looking at. Things like Euglena, Glyocapsa, and the like. Those are true alga. They're part of the verteplante, which is part of a different kingdom of life. They're part of the eukaryotes, whereas things like our nostoc are not part of that. They are bacteria, but due to the presence of chloroplasts, it's easier just to put them in. Now we're going to start looking at our cyanobacteria. This is nostoc. Also keep in mind that which while is I'm a cyanobacteria trying to stay up to date on the most recent of we're going to start with our 4 times objective, as always. It's incredibly difficult and bring it into view. Algae and bacteria in particular, because with the advent of modern molecular methods, it changes. When I was working on my bachelor's degree, I was working with an alga that started off as Monochrysis lutheri, and it ended up going through 4 different scientific names in 4 years. It ended up being Pavlova lutheri, and it's still, some people call it Monochrysis. We've seen this before as well. When we're talking about the differences between Cocuria, specifically Cocuria rhizophilia, and Micrococcus luteus. They are the same bacteria, but the modern designation is Cocuria rhizophilia. So a lot of times, and there we go. There's some nice bits that I'm going to be doing. Look at that beautiful thing. It will be me giving that is absolutely beautiful right there. That mean a lot to the people who know. See the individual cells. Something like a chlorophyte is an actual, which is a it's part of the phylum great thing. Remember, nostoc is a filamentous alga. Ways of doing this. We are going to try to look for like Heterocyst and Actinites, but we're going to have to zoom in for that. Taxonomic designation. So let's see about. Do follow along with the this video as well as the PowerPoint that will be posted up on Blackboard. And let's see how this looks on oil immersion. Don't focus too much on the phylogenies, but focus on the movement and what we go over with each of these, as well as where we put them in the domains of life. See if we can get a better look at. It's called Amoeba proteus, and this is not an alga or a bacteria. It's an amoeba, and it's a eukaryote, but it is not an alga. It's a protozoa. So yeah, we're not going to be able to get a very good view like a through this under oil, and we are slowly going to zoom in on our. But we're not seeing wonderful microscope here. Any algae to give you a nice view of what we have. Cut back, go to a different section. And hopefully the amoeba's moving. There's some movement. Excellent. I don't think I'm going to need protoslow for this. Protoslow, in this case, is a specific chemical. It's made by Carolina Biological, and it's a series of polysaccharides that, when mixed together, really make the movement of some of these organisms difficult. And we're going to leave it on this power here. And I don't think that's an amoeba. Nope, that is not an amoeba. 40 times. So I can tell just by the way of looking at this, that movement right there is not an amoeba. Cells right there. It's most likely something like chlorella. See any, but I think, let me zoom in here. So we're now at 40 times. Now, if we keep in mind, both the Heterocysts and the Actinites are in specialized cells. So, I mean, look at this. There's these chains of little green dots. Those chains are the individual cells. I'm going to try oil immersion again, just to see if I can get it to work. Since we are using oil immersion on a wet mount, it sometimes can be incredibly difficult to get it to work. I'd say it's maybe chlorella, but maybe we'll get lucky, and I can get a nice view of the cells. It might be, this might be amoeba here. Nope, that is an amoeba. It's just an amoeba that has recently eaten. Yeah, that's what I was afraid of. Yeah, there we go. Look at you.
One of the reasons
You
we
can
don't
see the
usually use
individual
oil with
chloroplasts,
wet mounts is
which
because
are
the
not
water
chloroplasts
itself
uses. That's just a
can be
alga that's
disturbed,
recently consumed.
and you can get this where you lose track
Oh, that is cool. It's
of your alga.
It's going straight up into us. That's awesome.
That's
Let me see
unfortunate,
if
but
I can
not
get
unheard
us
of.
some oil immersion. Typically, we wouldn't be doing
Next,
oil
we're going to look at
immersion,
Spirogyra,
but that's a cool looking
and let
discipline.
me
Let's see if we
find
can
us
get
some.
something with oil immersion, just to see. Worst case
We're going to
scenario,
start
we
at
go
4
back.
times, like always.
Yeah,
Aha, there we go. There's our alga.
The
I'm going to focus on this one right
organism.
here. We'll see if
That
we're going to be able
happens.
to see the spiral
So that was Amoeba
inside
proteus.
the sheath itself.
This next one we're going to take a look at is another.
Aha, there we go. So this is our 10 times, and you can see the spiral
protozoa. This one is called
of the
Paramecium
Spirogyra.
basaria.
That is just
And
gorgeous.
Paramecium looks
Test it, see if
slightly
we can
different
go up. See if we can
than the
see.
others.
Yes, we can. Beautiful. Absolutely gorgeous. See if we can zoom in on an individual cell.
Cells there, but
So this is just absolutely gorgeous. You can see here our individual cells. This is a cell right here, this large section.
That's fine.
With the spiral chloroplasts inside of it.
Now this is 10 times.
I mean, that's just gorgeous.
There's a bunch of cells.
Just gorgeous right there.
None of them look like Paramecium.
Now, that spiral that you're seeing is the chloroplasts and the paranoids. What's nice about Spirogyra, one of the few that we can actually see inside the chloroplasts, those small stackings.
Those are cells.
That right there are your paranoids.
Not Paramecium.
Since Spirogyra is a larger alga, it's difficult on others to see, but on this you can see the actual paranoids.
Find some better
I'm going to take a picture of this because it looks cool. That is just absolutely gorgeous right there. Now we're going to take a look at Eleutheryx. And here's our cells right here. Oh my. That's unusual. There's a lot of debris in this water, which I find unusual. But we're going to zoom in, take a look at that alga.
So, reminder that Paramecium basaria is a
and zoom in.
Again, it has a
40
symbiotic
times.
relationship with algae.
Oh, that's just gorgeous right there.
Unlike the other one.
So this is a broken, a fragmented cell. You can see that there's a fragment here and a fragment there.
The reason I don't think
you have your individual chloroplasts and paranoids all in this area here. And it looks like there's a bunch of fragmentation that came off of, maybe not this exact chained section, but others. I mean, that's just gorgeous the way it looks. Very good. Looks fairly healthy, which is good to see too.
That one right there might be.
Let's go back.
Now, I wasn't able to find a really good Paramecium, but I have a few videos that are from other locations in last year and the like. And I will go through those and see if we can find you a good Paramecium video. But for right now, we are going to be shifting to something that is significantly easier to see, and that is Chlamydomonas ronhardi. Now, this is a true alga, and you can see right with this is 4 times, you can see the movement as it is. Remember that Chlamydomonas does have 2 flagella. Now, we're going to start with not looking at this with protoslow. There should be enough cells that we should be able to get some good views of the Chlamydomonas without having to go down into protoslow. And here's 40 times.
There we go, right like that. Now there will be some streaking. You can see it over here. That's because these are moving organisms. But you can see that they do look like little circles under this power. And the moving ones, like that guy, like a little guy, they do have flagella. Now I'm going to try to zoom in on some of these. We'll go under oil immersion and we'll see if we can find some that are slow enough that we can see the flagella. No promises, of course. Whenever we're dealing with cultures, we sometimes don't have the luxury of getting perfect camera shots. So there we go. Now you can clearly see, I'm going to let it settle for a bit. You can see right here in particular on this guy, you can see the individual chloroplasts. Oh, there's one right there going to, and a two, and there we go. That little tuft, that looks like a little tuft of fur right there on the edge. Those are your paired flagella. Look at these guys. These guys are adorable. I love Chlamydomonas. So cute. It's like little green emeralds. And you can see that, like right there, that's a chloroplast, a bunch of chloroplasts within the cells themselves. Moving away from that, we're going to move to another alga. This is Oedgonium flavellatum. And right off the bat, we can see that there is Oedgonium here. Looks significantly different than the Chlamydomonas did. And we're going to see if we can find some fun things here. Let's zoom in. All right, there is definitely an Oedgonium right here. And let's see. See if we can find your heterocysts and paranoids. Remember, your paranoids are inside, so we aren't going to be able to see them yet, but you are able to find the heterocysts. Let's see if we can find some more interesting Oedgonium. You can see the heterocysts II that are in the water. Let me... Ooh, here's a really nice one. Ooh. That guy looks good. Yeah, let's take a look at this. He's not... Yeah. Notice how it is moving. That's because I hit the stage and the stage is moving. We're going to zoom in. All right, we're now at 40 times. And let me see if I can get us a knot. Ha, there we go. Here's the Oedgonium. And you can see the individual sections of this chained alga right here, here. You have your spores off to the side. Good. Oh no, it's broken. That happens. You can see here your chloroplasts, and inside of those chloroplasts are your paranoids. This is really nice. It's a good alga. The next one we're going to be looking at is Chlorella Perindosa. I did add protoslow to this. Chlorella as a whole can be, along with Euglena, can be extremely fast. So I did add protoslow, and that should make it easier for us to find a cell and get some nice shots of it. Here's some. Here's a nice lumping of chlorella. And we're going to try to go up to oil immersion on this. So next draw is going to be oil immersion. Let's see if we get anything nice on here. I did knock it when we went through oil immersion. Since we are doing wet mounts, it can be difficult at times. Let's saw something over a bit. 1 moment, me. So that's debris right there. There we go. There's some chlorella. Bottom right-hand corner is really what we're looking at. And is that a stopped one or is that a dead one? That's a stopped one. Now there are multiple planes. That's why I'm going through. So this is also a chlorella. You can see the green area. That is your cell. This here is your chloroplast, inside of which is your perinnoids. Not really seeing the flagella. That's unfortunate. But it kind of looks like a little emerald, and they are gorgeous to look at. I absolutely love some of these chlorophytes. Just absolutely gorgeous to look at. Now we're going to take a look at some Euglena. Also has been added with protoslow. In the lab, if you're coming into the lab to look at these, we will have the cultures available to you, and you can add protoslow on any of these. I just know for a fact that for the Euglena and the Euglena definitely needs it. And most likely the Chlorella as well, just because I've worked with these organisms. Let's poke around. Now, we don't know the species on this, but it's most likely Euglena gracilis. That's the common type. I think that's some right there. One of them's moving. Again, the reason they're moving so slow is because I did add protoslow. And we want them to move nice and slow. We want you to see the movement. All right, that's not what I'm looking for right there. Must be a fair amount of debris in this culture. And this is from wards. Yeah, it's not a culture I personally have. Let's zoom in on this one right here. That looks like it might be one. And I'm looking at this right here. Let's zoom in. I did zoom out again because I lost it, but we are going to take a look at this right here. That is 100% a Euglena. You can tell by its look, its shape. Let's zoom in. There we go. Looks like we have two overlapping each other right here. But this is definitely Euglena right here. Sort of an oblong shape. Right here. See the chloroplast and the paranoid. You can also see its entrenchment right there. That's cool. But yeah, there's your Euglena. Again, it's not really moving because we did add protoslow. And this is the 40 times objective. This next bit that we're going to be looking at are mixed diatoms. Now, diatoms are interesting because they have a silica outer shell known as a frustule, and they do have two different forms of life history. They have a sexual and an asexual stage. I have no clue which species are actually in here. If it's one that I'm familiar with, which are mostly aquaculture species,
I may be able to identify them, but there are so many diatom species that when you get a culture of mixed diatoms, you never know what you're actually going to get. Ooh, 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 ooh. So that looks like Nitzschia. Ooh, we're gonna look in there. That's cool. That's cool. Rare that we actually get Nitzschia in these. Maybe it isn't Nitzschia, but we'll take a look. Okay. That's on that didn't. I'll definitely be throwing up pictures that I have because I have a fairly large number of pictures of diatoms, simply because I've worked with them so much. It's always nice to see what we get. Yeah, there's not much here. Yeah, there's not much. There's a lot of debris, but not many cells. That's unfortunate. Well, these things happen. I'll definitely provide you with some cool pictures of diatoms. Now, this is our Galeocapsa species. I'm going to go up to 10 times. $40 times. Maybe having problems with our 40 times objective. That'd be unfortunate. There's some. There we go. There she is. Nice little small alga with the paranoids inside the chloroplasts. Next one, which are these filamentous-like branching, is osculatoria. Yeah, there's definitely something wrong with this objective. And now we're going to start looking at our cyanobacteria. This is nostoc, which is a cyanobacteria and not an alga. We're going to start with our 4 times objective, as always, and bring it into view. Swing up to 10 times. Swing up to 40. And there we go. There's some nice, look at that beautiful thing. That is absolutely beautiful right there. You can see the individual cells, which is a great thing. Remember, nostoc is a filamentous alga. We are going to try to look for heterocysts and actinides, but we're going to have to zoom in for that. So let's see about... And let's see how this looks under oil immersion. See if we can get a better view under oil immersion. Yeah, we're not going to be able to get a very good view through this under oil. There's some air bubbles, but we're not seeing any algae. Cut back, go to a different section. And we're going to leave it on this power here. So our 40 times. Long cells right there. I don't see any. Now, if we keep in mind, both the heterocysts and the actinides are in specialized cells. So, I mean, look at this. There's these chains of little green dots. Those chains are the individual cells. I'm going to try oil immersion again, just to see if I can get it to work. Since we are using oil immersion on a wet mount, it sometimes can be incredibly difficult to get it to work. But maybe we'll get lucky, and I can get a nice view of the cells. Yeah, that's what I was afraid of. One of the reasons we don't usually use oil with wet mounts is because the water itself can be disturbed. And you can get this where you lose track of your alga. That's unfortunate, but not unheard of. Next, we're going to look at Spirogyra. And let me find us some. And this, we're going to start at 4 times, like always. Aha, there we go. There's our alga. I'm going to focus on this one right here. We'll see if we're going to be able to see the spiral inside the sheath itself. Aha, there we go. So this is our 10 times, and you can see the spiral
of the Spirogyra. That is just gorgeous. I'm going to test it, see if we can go up. See if we can see. Yes, we can. Beautiful. Absolutely gorgeous. See if we can zoom in on an individual cell. So this is just absolutely gorgeous. You can see here our individual cells. This is a cell right here, this large section, with the spiral chloroplasts inside of it. I mean, that's just gorgeous. Just gorgeous right there. Now, that spiral that you're seeing is the chloroplasts and the paranoids. What's nice about Spirogyra, one of the few that we can actually see inside the chloroplasts, those small stackings, that right there are your paranoids. Since Spirogyra is a larger alga, it's difficult on others to see, but on this you can see the actual paranoids. I'm going to take a picture of this because it looks cool. That is just absolutely gorgeous right there. Now we're going to take a look at Eleutheryx. And here's our cells right here. Oh my. That's unusual. There's a lot of debris in this water, which I find unusual. But we're going to zoom in, take a look at that alga. Yeah, there we go. That's what we're going to take a look at. And zoom in 40 times. Oh, that's just gorgeous right there. So this is a fragmented cell. You can see that there's a fragment here and a fragment there. You have your individual chloroplasts and paranoids all in this area here. And it looks like there's a bunch of fragmentation that came off of, maybe not this exact section, but others. I mean, that's just gorgeous the way it looks. Very good. Looks fairly healthy, which is good to see too.